Mr. Sutton here, bringing you the Algebra 2 and Algebra 2 Honors Chapter 3 Quiz 1 Review Solutions. This one on solving quadratic equations with square rooting, factoring, and completing the square, and also with complex numbers. For this first problem, we need to solve this equation using square roots. So the idea here is we're going to isolate this x squared term and then take the square root of everything. So we'll start by adding 97 over to the other side. That'll give us 98 over there. And then dividing by 2 gives us 49. And then finally, now that I have x squared truly by itself, I just square root both sides. I just have to remember that when I square root an equation, I get a plus and minus square root of the other side. So this will be plus or minus 7. To solve this equation by factoring, as they're asking me to do here, I'm going to need to zero out this equation. So that means getting the 24 over to the left side by adding it there. And now that I've got this zeroed out, I just have a 1x squared, so I'm just going to try the normal way of factoring. I'm just going to ask, what are two numbers that multiply to 24 and add up to negative 11? Well, let me think here. 1 and 24 doesn't work. 2 and 12 doesn't work. 3 and 8 would work if I had negative for both of those. So I can split this up into x minus 3 and x minus 8, all of that equaling 0. And now that I've got this factored and I've got a product that equals 0, I can use my zero product property and just set each of these individually equal to 0. So if x minus 3 equals 0, then x equals 3, and 8 will zero out this other parentheses. So those are my two answers. For this problem, they want us to find the square root of negative 98. Now, since I'm taking the square root of a negative, I have to take an I out of there, where I is just the square root of negative 1. So taking that out of there gives me a positive 98 inside, which I can now treat as just a normal radical that I'll simplify. So are there any perfect squares that go into 98? Well, let me think. 4, 9, 16, 25, 36, 49. 2 times 49 is 98. So let me split that up into 49 and 2. And then if I take the square root of 49, that's just going to be 7. So we then have a 7i radical 2. On this problem, we're just trying to add these two complex numbers together. First step is to get rid of these parentheses, distributing anything that we need to. Since I have nothing in front of this one, it's just an invisible 1, so I can just lose that parentheses for free. And this plus parentheses is also an invisible 1 getting distributed, so I can also lose this second parentheses for free. Next up, totally optional, but I'm going to group the like terms together, so 13 and 6, and then the 8i plus the 3i. And then I'll just combine the like terms. So we have 19 plus 11i. On this problem, I'm trying to multiply these complex numbers together. I'm going to start this by just foiling, distributing this like I would for any sort of problem that looks like this. And then we'll deal with the I squared a little bit later. But first off, we have firsts gives us 45. And then 9 times 2i is going to give us 18i plus that. 8i times 5 is going to be a plus 40i. And 8i times 2i gives us 16i squared. The 18 and the 40 can be combined to give me 58i. And then I squared, remember, is really negative 1. So this will be a negative 16 that I can write that as at the end. And then 45 minus 16 gives me 29. So 29 plus 58i is as simplified as this gets. For this problem, I'm trying to solve this equation by completing the square. So in order to do this, a couple steps I need to take. First, I'm going to divide everything by 9 so that I can have just 1x squared. So that'll give me x squared plus 2x plus 2 equals 0. Next up, to complete the square, I need to clear out this constant by moving it over to the other side. So I'm just going to subtract 2 over there. And now to do the actual completing the square step, I have to take half the b value, so half of 2, which is 1, square that and add that to both sides. Now, since it's just 1, you could have gotten away with not squaring it, but you really should square it just to get in the habit of it. Because if this had been like a 10, then I would have 5 squared, which is very different from 5. So make sure you're squaring that to actually complete the square. So on the left side then, I'm going to have x plus 1 quantity squared. On the right side, this is just negative 2 plus 1. And then if I square root both sides, I've got x plus 1 on the left, and this will be plus or minus the square root of negative 1 on the right side. And then I'm going to do 2 steps at once for my last line here. I'm going to subtract this 1 to get it over there, get it away from the x. And also, the square root of negative 1 is really just I, so this is just negative 1 here, plus or minus I. On this problem, which is on the honors review guide here, we're trying to find values of x and y that satisfy this equation. So the trick on these is just to take the real expressions, the 3x and the 15, and set those equal to each other, and then do the same for the imaginary components, and that'll help us isolate and solve for x and y. So I'll start by doing 3x equals 15, and then dividing by 3 we get x equals 5. And then I can do 2i equals negative 12yi. And then if I divide both sides by, let's see here, I got to divide by negative 12, right? So that's going to give me 2 over negative 12, which I can reduce to negative 1 over 6. For this problem, they just want us to write this quadratic function in vertex form. So the way we're going to do that is we're going to kind of section off this x squared plus 10x, and then we'll complete the square just for this little piece. So let me put a parentheses there just to show people what I'm about to do. And in this parentheses, I'm going to complete the square. So I take half of 10, which is 5. That's my b value I'm taking half of. So I'm going to square 5 and add that inside the parentheses, and also on this other side. Now, if there had been a number outside this parentheses that I factored out initially, I'd have to multiply this 5 squared by whatever that number was. Since there's just an invisible one, I'm not going to worry about that. So simplifying things, we've got g of x plus 25 on the left. On the right, this can be factored into x plus 5 quantity squared, and that 13 is still there. And then finally, just subtract 25 from both sides. That gives us x plus 5 squared minus 12.